Good morning. My name is Miguel Moreno, and I will show you my presentation titled FireDAC Migration Made Easy. BDE, dbExpress, AnyDAC, and non-integrated FireDAC to full FireDAC. Let me show you a quick introduction of the concepts we will see today. This is the history of the database components and technologies that have been traditionally included with Delphi and C++ Builder. First of all, the Borland Database Engine, or BDE, dbGo, or former ADO-Express, Interbase Express, or IBX, dbExpress, or dbX, DataSnap, formerly known as Midas, and last, FireDAC, formerly known as AnyDAC. The Borland Database Engine, or BDE for short, has a native model that supports flat file-based databases in two standard formats: dbase, supported from version 3 through 7, and Paradox, which is also supported from version 3 through 7. It includes an ODBC bridge to connect external databases that have an ODBC driver available. This is only in traditional ANSI mode. There is no Unicode support. It offers heterogeneous data sources integration via built-in local SQL feature. This feature is internally using temporary tables in Paradox format. This technology has been deprecated and been obsolete since the year 2000. It is no longer automatically installed in RadStudio 10.0, but it is available as a separate manual install download. It has surpassed its own time, so you must migrate immediately. It could no longer work in newer versions of Windows or after installing a service pack or security patch from Microsoft. dbExpress is the data driver architecture that replaced the Borland Database Engine. It was first released with Borland Delphi 6 and C++ Builder 6. It has gone through several iterations itself. It provides unidirectional database access. That means that you can traverse data obtained from a database table only in the forward direction. You cannot go back unless you add other layers. This makes dbExpress a very fast access technology compared to many others. Updates have to be done with help of the companion database provider and the client dataset, which assemble automatically appropriated update, insert, and delete statements in SQL. It includes drivers for many databases, including Oracle, Firebird, Interbase, DB2, Informix, SQL Server, MySQL, and an ODBC bridge. Additional drivers are available from third parties. Starting with Delphi 2007, dbExpress 4th generation, a tracing driver is included as well, which allows for logging all the statements sent to the database. Prior to version 4 of dbExpress, the drivers used the Microsoft COM technology internally, and most drivers were not Unicode enabled. Nowadays, the drivers are written in Delphi itself, and the source code for most parts is available. Most drivers today are Unicode enabled, since Delphi itself switched to Unicode with version 2009. What is FireDAC? FireDAC is a database driver architecture and components formerly known as AnyDAC, and they were developed initially by a third-party vendor. FireDAC's technology is very robust. Its predecessor, AnyDAC, was already in version 6 at the time Embarcadero Technologies decided to acquire its technology. It is now the officially recommended solution by Embarcadero for any database access in RadStudio 10.0. It natively supports 12 types of database engines: Advantage Database Server, IBM's DB2, Interbase, Firebird, Informix, MS SQL, MS Access, MySQL, Oracle, PostgreSQL, Sybase SQL Anywhere, and SQLite. It also includes 3 bridge drivers or connectors to attach to several other database engines that are not supported natively. These are an ODBC in both ANSI and Unicode support, DataSnap, and the dbExpress bridge. It offers heterogeneous data sources integration via built-in local SQL feature, which is internally using the SQLite engine with its virtual tables feature. FireDAC availability in Delphi and C++ Builder. The very original AnyDAC was available for Delphi ranging from version 5 through XE2 and its equivalent versions in C++ Builder. Embarcadero now includes FireDAC with its compilers starting in version XE3 of Delphi and C++ Builder. However, all components and source code still have the AnyDAC naming convention. These earlier Embarcadero versions of FireDAC are generally known as the non-integrated FireDAC versions. Starting with version XE5 of Delphi and C++ Builder, Embarcadero includes FireDAC with a completely new components and source code naming convention that closely matches the new naming of the library. These later Embarcadero versions of FireDAC are now generally known as integrated FireDAC versions. This is the internal FireDAC architecture. You can see that at the very top level we have Delphi and C++ Builder with the BCL and the FireMocking application platforms and frameworks. At the middle layer we have FireDAC with the non-visible components, local data storage, data adapters, and you can see all the native drivers that are natively included and do direct access to the clients of each one of the supported database engine clients. At the very right, you can see the bridging drivers, which are the ODBC and the dbExpress one. There's also a monitoring feature in FireDAC included, so you can also trace all commands being sent between your application and the database server. Now let's review the database engines from a BDE migration point of view. We have personal versus multi-user versions and modes. Before migrating a BDE application to FireDAC, you must analyze the mode of the original BDE database is being used. In a personal or single user mode, only one user or client has access to the database. Usually, the application is being installed in an individual computer. In multi-user mode, several users or clients have simultaneous access to the database. Generally, it is installed in a server inside a computer network. So this is the recommended migration path for FireDAC of personal versus multi-user databases. At the top, you see the BDE engine type being used of the internal connection or data storage format. So if you are migrating from a DBase or Paradox data engine, then if you are in a personal or single user mode, the recommendation is to migrate to Interbase. You can go to the Interbase Lite, which is free, no licenses needed, but is limited to 100 megabytes. You have the to-go version and the desktop version. As an alternative, you have the SQLite and Microsoft Access for single user, one station mode. DBase or Paradox in multi-user mode, the recommendation is to go up to an Interbase full-blown server, because this is easy to manage compared to any other server option. As an alternative, you can go with Firebird, MS SQL, MySQL, Oracle, PostgreSQL, Sybase SQL Anywhere. If you had the BDE connecting to an SQL engine via the ODBC bridge in a personal or single user mode, then you can keep using that SQL engine. So now you would use either the native driver if included in FireDAC. If not, then you can still use the built-in ODBC driver bridge from FireDAC. As an option, you can migrate to Interbase on any of the 3 versions, IB Lite, to go and desktop. And then you get rid of a server if it is intended to be on a single personal use. On an SQL engine via an ODBC bridge in multi-user mode, the recommendation is to keep using that SQL engine and move to the native driver if FireDAC supports it, or keep using the ODBC bridge driver if it doesn't support it natively. As an option, you can go up to an interface server, and if you want easy management, or the SQL engine that you are migrating from is no longer supported by the vendor. So these are the steps you must follow to migrate a BDE application to FireDAC. First, you must select the new database engine to be used in the migrated application. For that, you can use the previous table as a guide. Then you must recreate the original BDE database structure in the new selected database engine. Then you have to migrate or move the original BDE data to the new database engine. Later, you have to replace the BDE components in your original application with the equivalent ones in FireDAC. Later, you must redefine or adjust the FireDAC data connections to point to the new database engine. Then, you redefine or adjust the mapping for the fields data type if required. The internal programming interfaces or APIs of the BDE and FireDAC are completely different. So if you have code calling directly to the BDE API, you must rewrite that piece of code from scratch to utilize the new FireDAC API. If you make use of the BDE local SQL feature, you must recreate that functionality using the new local SQL feature provided by FireDAC, which is based on the local SQLite driver with virtual tables. This is a table quickly showing the BDE components counterpart in FireDAC. These are the components that you must replace with individually, one by one, in your old application being migrated. This reference is also available in the help from RAD Studio, Delphi, and C++ Builder, as well as in the online documentation from Embarcadero. Conversion of BDE aliases. If you want to migrate or convert BDE aliases to FireDAC, you can use the included FireDAC Explorer tool. You launch the tool and select the menu option Connection, Import BDE Aliases. The tool will then create FireDAC connection definitions equivalent to your BDE aliases. Now I will show you the sample number 1, migrating a BDE application to FireDAC. This is the directory where I am putting the sample applications that we will convert today. The first one on the list is the one for the BDE conversion. Here we have the application. Let me load it up in C++ Builder. So again, this is the list, BDE, original version. We load the application. This is a very simple contact manager that relates two of the tables that you have available in shared mode. That uses the data that you have in the standard Embarcadero data demos. So these are the files used by this application, standard Paradox and dbExpress files. This specific application uses customers, customer DB, and orders DB. Orders DB. let me show you how it works. We launch the application. This is the standard form, and this is the data module. A T query from the BDE and a T table. They are linked on a master-child relationship. Customers is the master table, and with the data source is driving the orders. So let's run it. We have a customer orders browsers. We browse here, changing the customers. Here we change the initial name of the customers. And here we browse all orders for that specific customer. So very simple, but enough to show almost all features that we would normally need, meaning opening data, having edit fields, browse fields, and a master-child relationship in the tables. We go out, and according to the list of steps that we need to follow, the very first thing we need to do is migrate the paradox data that we have here. We can get use of the FireDAC Explorer that we have. And you can use several methods to export your data. In my previous presentation of scripting with FireDAC, I showed a way to do a massive export of data and then import it into another database. So you can see my documentation at the end if you want to review that presentation. Well, anyhow, the thing is that you create a new connection definition. In this case, we are calling it IB must.dat. This is already created by the demos included in CB++ Builder. This definition is pointing to the RAD Studio location of the data, and this is an interbase database that has exact same tables as the Paradox version. So this only saved me from doing the conversion, but you must do it for any type of data that you will be migrating from the BDE. Again, if you want to see my previous presentation, there's some way that FireDAC can help you by some scripting to do the massive load and download and upload into another database. So we already have that data converted to interbase. I created this connection definition name, interbase master data, all the definitions here. So once I connect, we can see that the tables are here. So this is the one that we need, customer. This is the data of customer and orders. So I'm done with migrating my data. I already selected a new database, an SQL database. I chose interbase, and I moved the data structure for both customer and orders, which are the tables I needed. This is the structure of each one, but now in interbase. And once these tables were created, the data was moved from the Paradox version into this interbase-based one. So this is the exact same data that I used to have on the Paradox tables. So now that we have that done, then we're ready to continue with now migrating the code and the components. So what we're going to do is close the application in order to create a clone. We go here, do a copy and then a paste. We will call this copy migrated. I remove these references, which only make noise. And I remove all local project references, so they don't make noise again with my conversion. I remove all the internal directories that the former project had. So I created and cloned the BDE migration to migrate it. It is worth mentioning before I go ahead that there is a provided tool with FireDAC. It's refined, and this is a sample of one of the definitions that refined includes to do a migration from a BDE. The only one issue is it's not fully supported with C++ Builder. And I'm in the progress of creating a tool which I wanted to show you that does exact same purpose as the refined tool, but for C++ Builder. It will work with both C++ Builder and Delphi. So the issue is that the FireDAC built-in utility called refine is not 100% working now with C++ Builder. So I'll show you the manual steps that you must take in order to do the conversion. This is our original. I go back to the parent directory, so I switch to the migrated one. We load it up. Since I deleted the disk, I'm not able to see it. View source, context main, okay, and the data module. This is the main source, and the data module is here. Okay, got it. The first thing we must do is go to the data module, and we're going to migrate to FireDAC. So if you see the table of equivalent components, the equivalent for a T query will be a FD query, FireDAC query, and the equivalent of that table will be a FD table. Before I do that, I'll temporarily rename this so I don't mess up with the code that it's already calling these tables, so I can rename the new ones. FD query, we dropped the FD query. Now we dropped the FD table. And now we need the connection. Since these were already connecting to an alias, alias will make sense if that alias was connecting to an SQL server. In this case, they are not. They are connecting to an old style flat file paradox format. So this alias is of no use to me. I don't need to convert it. What I need to do is now add a FireDAC connection component that will connect to the database that we created with these new tables. Okay, we load it. We select the interbase driver. We can borrow. This is beautiful about the FireDAC Explorer. You can just take the exact same definitions that you already created here and copy paste into your new. This is the FireDAC Explorer. I do copy, go to my application, I paste them here, go to the FireDAC Explorer again, and then we are set. We do test in the FireDAC connection component. Connection established successfully, so my new connection works fine. Now I'm in the component I added in my C++ Builder application. Once I have the connection, I'm gonna borrow the SQL entry that I have here. I do double click here. I make sure that the connection is connected on both the query and the table. I go back here. Now that the connection is there, this parameter is automatically parsed and added by FireDAC to the internal collection for parameters. This is an input parameter, string type, and I'm going to put the initial value. In this application, it's driven by the initial letter, which is driven by the tab of the browser. So now that I have defined the parameter and with an initial value, I can test it right here. Customer DB. That's my mistake. That's the kind of issues you need to do. You need to adapt the SQL. So even though it's the exact same SQL, I must remove this reference to a paradox table. So now I go back, and now it worked. These are all the customers starting with A, grabbed from the interbase database. So my query has been adapted. It works. I will change the name of it to say customers. So I keep the exact same name of the component, and I don't need to change references on the code in the main application. All the code that is in the form is making references to the tables. So if I make sure that I keep the exact same name of the component, then I don't mess up with this code. Almost nothing needs to be done on that side. Second thing, once that this is working, I need also to add all the fields in case you're using persistent fields. Just do a right click, add fields. So customers is being taken care of. Now I will put these two apart. My data source needs now to be pointing to the new customers. So the data source is there. This table does not have an index. This one had an index. So I must create an index here. And we do that by going to index field names. I haven't selected the table name yet. I must select the table. It's orders. So I can now select the field name. So not this, I need customer number. That's the one that needs to be driving the index. So I've selected the field that drives the index. Now I need to select the master source, customers, the master fields. So guess what? It seems that this won't work because we cannot set a master-child relationship without having a parameter. This is one of the examples of some features that are not exactly one-to-one replacement from BDE to the FireDAC. The BDE was doing the trick of having a child relationship in a table by using its index, and it internally faked like having the parameter driven by the master table as the one driving directly the index. But that's something you can't replicate with an SQL database. What you do in an SQL database is pass that value of the master field as a parameter to the internal query of the data source you have here. So it won't work with a straight table. So we will replace the table with an FD query instead. So we can build a query that will give exact same results as the ones intended originally. I put a query here. We connect, and when we define the SQL, we need to type an SQL command that will do the exact same thing. We will get the data from orders. And we need to add a parameter, which is the parameter driven by the value we get from the master table. Customer number equals, then the parameter customer number. FireDAC has automatically added this parameter for me. It's already here. I just need to specify this is an input parameter. This is a float value. You can tell by going to the Explorer, opening the orders table, browsing the columns, you see that customer number is a float value. We go here to the float. I need to borrow one valid customer number so I can validate that my query works. I'll borrow this one, 2163. Once I've accomplished that, I go back to my query and execute it. Line 1, oh, I have a typo here, select. Okay, we execute it. That's it. We're getting all orders for that sample customer number. So the query is working. I can go back to the data module. I'll change the name of this one to orders. Once we do that, we point the master source to the source of customers. Now you see the magic of FireDAC. It automatically guessed that that one parameter that I added has an exact same name matching field in the master table, so it already filled it up for me. I didn't need to do anything about it. So that being said, this is ready to go. I can remove my former BDE components. I already created the fields for this one, the persistent fields. Now I need to do the same for orders in case I'm using those persistent fields in my code. So now I have a FireDAC version of my components. Everything has been taken care of right here. You already know that you can test how this is working by opening the field editor, that it's also the record browser. So if I open up customers and then I open up orders, I can see how by moving here, this one will have also browsing capability. So I close these two, I disconnect them, disconnect this. Now I have already taken care of the data portion. I need to go to my visual forms and make sure that they now point to the new components. So this data source is conveniently named customers, so I remember that this is to be pointing to customers. This data source is named orders, so this should be pointing to orders. I will change now the title, migrated. Then I execute it to make sure that it's working. Remember that I told you that I kept the exact same component name, so I don't need to modify my code. But before we go ahead, you must clean up all the libraries and units that you are not using, so it doesn't try to initialize the database engine. So we go to the H file, remove any reference to the BDE. In this case is BDE tables. We remove it, then all these ones were added when I added the FireDAC components. Those ones stay, no problem. Then I go back here, make sure you force a build, so all code is compiled from scratch again. So we do a build. Then we run it. This is one of the things that I intentionally left here for you. FireDAC has visual components that are not tied to a specific technology. In other words, the BDE is completely tied to the BCL by design. FireDAC is not. So FireDAC doesn't know what type of project you are compiling. It doesn't know whether you are creating a VCL standard application or if you are creating a FireMonkey application. So it's up to you to provide the visual elements to FireDAC. Which visual elements, you might ask? Well, in this case, it's talking about the wait cursor that is shown when a query is being executed. So it's telling me that I didn't add any wait component to show the cursor when it's executing an SQL. So I must go back here. I go to my data module. I select the wait cursor by FireDAC. Since I am in a VCL application, the component palette already gives me only those available for VCL. So I don't have any problem just selecting the first one that comes with a wait cursor. So that being done, I can compile again. I need to compile again from scratch and run my program. And you can see that our former BDE program Now it's fully working with FireDAC. And the query I had to use to replace the table, the T table, is now working the way we expect it to work. So this is, although the application is simple, is showing us a lot of things that you must consider when you're doing a migration. And not all of them can be automated. You must do some human interaction in order to replace things the right way and behave it the way you want it to behave. Okay, we are done with our BDE migration to FireDAC. Now, I will show you my sample number 2, how to migrate a dbExpress application to FireDAC. We are back at our main directory showing the samples that I'm converting today for you. Number 2 in our list is the dbExpress application. So I will open it up with C++ Builder. We browse to the directory dbExpress original. We open it up. View source, context main, context data. So this is our application done in dbExpress. You might recognize the complexity of dbExpress, where you need to have up to 3 components in order to get the data. The unidirectional dbExpress components that actually get the data for you, the dataset providers to connect them to T-client datasets, which actually do the browsing and edit functionality for the end user. And they get connected at través the dataset through the dataset providers back to the connection to the database server. Let's try the program to see that it works exactly the same. I call this one dbExpress original. I had also to replace the T table with a query for the exact same reason we had to do it with the FireDAC conversion of the BDE original program. Because in order to replicate the behavior of driving the detail with a parameter automatically updated with the master table, only with a query we can accomplish that same functionality. Let's run this program. And here you can see the dbExpress program behaving identical to the original BDE program. This is a conversion that I had to do just to show you the same program, same behavior, but with dbExpress components. So now let's convert it to FireDAC. First thing we're going to do is we're going to clone the whole application directory. So we can do the copy. So copy, paste. We're going to call this one migrated. We need to go inside, delete all these directories to remove any garbage that this will make cause. You know what I'm talking about. We need to remove the disks, the disk components with the local project. And that's it. We're leaving just the raw source code needed for the project. We open it up in C++ Builder, but now we need to go to the migrated one. We open it up, we go again, we show the original source, and when we go to the data module, and this is the one we need to play with. I'm gonna do exact same steps. I'm gonna go a little faster so we don't waste time doing a lot of explanation. And you basically understand what's going on with the dbExpress components. We're replacing all this set with just 3, the 2 FireDAC queries and the data source component. So these are the end user components that are being counted, being seen in the application. So the application is expecting to keep these exact same names, customers and orders, same as we had on the BDE one. So I temporarily rename it so I can drop the new FireDAC versions and plug the name on them. So I'm going to move this temporarily down. First of all, we add the FireDAC connection. We do the definition of the interface connection, same as we did with the previous one. Okay, we are set. We say test. It connects. We have the connection. We drop the new FireDAC queries. One, two. We'll rename them. Now here, since we already have queries in the original dbExpress, we just borrowed that exact same query. I don't even need to translate it because the one for dbExpress was already adapted to interface. In case you are moving to another database engine, then you need to look for any possible modifications in your SQL command. We already pasted the SQL command, so FireDAC added the parameter for me. I need to define it as an input one, string parameter. I put the initial value here, %, then execute it. Okay, we are set. I go to the connection, remove the login prompt. I will do the same for the orders. I borrow the query that I already had here. We paste it here. This parameter has been already recognized by FireDAC. I just need to tell it that it's an input one. The data type, you must recall, was a float type. And the number that I had sampled was 2163. So I can go back and then test it. It's working. So once it works, I exit, add persistent fields so the application can still see them. Add persistent fields here. They are working. Now I move my data source here, point it to the new customers rather than the old one. I can now get rid of all these ones. Bye-bye. And now I go to the detail table. I will select the master source customers one. You see, again, FireDAC could guess by trying to match the name of the one parameter I have on this query. It immediately guessed that this was the correct master field because it has the same field name. So it's wise for you in FireDAC to always use parameters that have exact same name as the master field name. So it will almost always guess it right for you. Okay, so we have this one ready, this one ready. I already changed the names and the data source is connecting. I only need to update the data sources on the main form. So this one that is conveniently named customers need to point back to the new customers. And this one conveniently named orders now needs to point to the new orders. Same as the original, I will replace the name here, say migrated. I'll go to the data module and remove any reference to, I need to save it first. Once I save it, RadStudio adds the entries in the H entry. You see all the FireDAC entries, but I must remove the ones for dbExpress. This one is the generic database component. You don't remove that one. You remove the other ones, but not that one. All these are related to dbExpress, the ones that need to go out. I'm done it, I save it. But before we do that, we already know that I can make the same mistake as before, so I will simply remember to add the visual components required. In this case, the bare minimum required is the weight component for FireDAC. Weight. Okay, I have the weight cursor. So now I can force a rebuild from scratch. And run my program. So we have our dbExpress program migrated to FireDAC. Exact same behavior. And actually it becomes much simpler. FireDAC components replace the dbExpress and you get rid of a lot of components. Finished. And now the last sample code in my presentation, sample number 3, how to migrate an AnyDAC non-integrated FireDAC application to FireDAC. So I'm at the directory of the application that I will convert the last, AnyDAC and non-integrated FireDAC. I will open up the application, the original one. I must do a cloning. I will show you first the original one. This is the exact same contact browser application using AnyDAC or non-integrated FireDAC components. Now, some of you might get confused because you didn't know about the existence of AnyDAC before Embarcadero acquired them. So, as I had shown to you before, there's the original AnyDAC library, which has components starting with AD, TAD query, TAD connection, and so on. And when Embarcadero first acquired FireDAC, they put that brand new name, but the code was still using the old AD AnyDAC naming convention. So for the first 2 releases of FireDAC, after XE2, we had XE3 and XE4 that kept using the old AnyDAC naming convention. Finally, Embarcadero integrated FireDAC in the IDE and the full compiler, and then they made a global change of all units and components to FD, matching the FireDAC new name. That was done in XE5. So some users that got FireDAC in the earlier versions and users that were using AnyDAC before the library was acquired by Embarcadero are now facing this problem, that they cannot simply open up those older projects because the naming convention is not matching the new one, which is the final one for FireDAC. So this might look stupid, but that's happening, and many users, such as me, are facing this issue. What we're going to do is convert it to FireDAC. So we close here, we do the cloning. We rename it to say migrated. That's it. Now I can open that one up again. I go to the migrated version. I opened it up. I show source. I show data. Again, I go to the data module, which is the key one I need to work with. And we will do the exact same thing. We will add a connection first. FD connection. But there's a catch. If you didn't notice, I'm in C++ Builder XE2, not 8, not 10. The reason why is because I needed to show you that these components exist, but using the former AnyDAC or non-integrated FireDAC components, which were available with XE2, 3, and 4. So just to let you know that the components are here and then it works. But what I need to do is open it up with our latest version of C++ Builder, only that these components, when loading up, will yield an error and those won't be seen. So it might look like harder for us to work with. So once I open the migrated version of the program in a newer version of XE7 that does have integrated FireDAC, those components will be gone. And then integrated, migrated, so migrated version, I open it up. You see, so AD connection not found, ignore. AD query not found, ignore. AD query not found. So the only thing that was left for me was customers. So you need to write down which components were there, because they will be removed once you open up your new C++ builder with integrated FireDAC. So I will quickly plug the components that we have been placing. First, we do a FireDAC connection. We plug the two FireDAC queries. I will rename this query for customer. I can rename this one. I define the connection, same as before. Test the connection. It's working. I go back. Make sure the connection is set on these two. I write down the query again from scratch. Go and change the parameter to be input string, a starting value. Run it. It's working fine. I exit here. Add the fields. Okay, it's done. Select. We go here. A typo. Parameters. We say input. It's float value. On the sample we've been using 2163. We execute it. It's working. This one will be connected to customers. Now here we define the master source. Cost number has been automatically updated for us. We go back here, point the data source to the new customers and the data source to the new orders. We need to add the fields. Edit it from here. We do it here. Okay, they've been added. So we have the new version of FireDAC converted from previous AnyDAC non-integrated FireDAC. We remove the components. We need to add also the weight cursor. We have added the weight cursor. We remove the previous references to AnyDAC. So you see that all these AnyDAC references need to go. And we finally run the program. And we have the new version of the former AnyDAC non-integrated FireDAC converted, same as the rest. So that's it for now. Additional resources and documentation. FireDAC online documentation contains a fairly good amount of detail about the FireDAC migration process. I agree that it is confusing, it's cumbersome, even though there are some tools like the refined utility to help, still there's a heavy task to do the conversion. But I hope that by what I have shown you here, you might find a path to do a smooth migration for the application you want to move to FireDAC. The URL for the online documentation of the migration of FireDAC is, as you can see here. And also you can download the full sample source code of this presentation and more resources and documentations that I will make available on my own site, delphiguru.net. Thank you so much for your time. Now it's time for questions and answers.
DelphiGuru.net is the right place for people to go, right?
Sure. Only right now, this second, I'm moving to a better hosted site, so might wait for 1 or 2 days. I'll be posting the full presentations that I have shown this time, the one I showed 2 days ago, plus this one. All source code and the presentation will be available.
Okay, great.
Also as usual, it will be also a companion to the ones you will be posting for the Code Rage official site.
Okay. So then when you get any updates of the presentation part, video parts, just upload to the FTP site and we'll take care of our end. But having it linked off your site is great to your files, video files and source code and everything is great in both places. So
sure.
Excellent. Let's see, Vladislav is saying, thanks for a brilliant session. Great, that's great to hear. Sigbert was saying, what about the available databases with FireDAC? I put the link to the FireDAC wiki, sorry, the FireDAC wiki, where we have links for all the database connectivity that's available in FireDAC, and you can drill down inside of that. I put that in the chat window as well, that link. So on the doc wiki, it lists all the different databases we connect to and has all sorts of additional information. When you click on each of the links for each of the databases, then it'll give you more information about what we do and specific things we do for specific databases. There was this question about, to switch to another database, you just the FT connection component and everything just works, right? And that's the go ahead.
Yeah, the one thing that I felt a little pressured because having to show the 3 modes to migrate an application didn't give me a lot of time. If it was only the standard BDE to FireDAC, I would be showing more issues that you need to solve when doing the conversion. One that I intentionally didn't show here, but you must do, is especially when moving from the BDE to FireDAC, many of the field types get mapped differently. And you find about that only when you try to run your program, and then you get a lot of exceptions because the data being gathered by the component is not matching the one that is defined on your code or the one that you made formatting or conversion utilities for. But then it's very handy that FireDAC, some of the things that I really love about it is the mapping of the field types using the FireDAC manager. That one feature I didn't have enough space to show here, but that's something that it might come handy, especially with complex projects. That almost always happens. So you must bring the mapping utility to solve mapping issues. But that's a great feature FireDAC has.
Yeah, there's a whole metadata query system. You can see that in samples and in the doc wiki. You can always query the types of columns and go and write code to handle the differences for different databases, so you can do that in code. Yes, and FireDAC does a lot of work under the covers to help, and there's lots of notes about working with metadata and working with different databases. There was another question here about when you do FD query and you want to, you may not want to bring all that information over. FireDAC has a setting for how many rows can be returned at a time, and as you then move your cursor, it'll go and get more rows, right?
Well, by default, FireDAC has limited row set, so it's gathering them on demand. It doesn't get them all at once. That's by design, which is fine. But there's this catch. If your
application requires that you have a index in place the very second that your application starts up, then automatically it'll have to gather it all. What happens is that an application that would normally start up in 2 seconds would then require up to 30 or 40 seconds because you enforced the use of an index. And in order to put the index in place, it must gather all the data. So you might see some delay. If that happens, what I usually recommend is put some on-screen comment telling the end user that it's doing something. Otherwise, they will go crazy and double-click on the application again and again.
And a few people have been asking about calculated fields and other kinds of things. You can still use T-client dataset from the Midas technology.
Yes, you can, but you know what? I wouldn't do that. There's even some presentations done by Kerry Jensen, and every FireDAC user has witnessed the speed improvements by using the mem table in FireDAC, which, by the way, is included in the T-query. Actually, the FireDAC query is a combo of the mem table plus the internal commands that gather the data. It's only been unified in one single component, but especially with big row sets, I have witnessed a huge performance improvement compared to the T-client dataset.
I don't remember if FD mem table, I guess you could always write code to do calculated fields or calculations, right?
Correct. Yeah, in any component, either the separate mem table or the standard query, you can do calc tables. Yes, no problem. I mean, calculated fields.
Yep.
Calculated fields are completely supported on any component provided by FireDAC. So no problem if you have calculated fields in the BDE or even in dbExpress, no problem. They are fully supported.
Yeah, so you had just mentioned that you were moving DelphiGuru.net because Sigbert is saying that it's an empty WordPress page right now.
Yes, I'm moving it. I'm moving the host. So right now I was busy finishing the presentation, and wait just 1 or 2 days and the full thing will be moved to this new hosting site.
Okay, got it. Let's see. Is there any other tips to reduce the amount of memory used by FireDAC when you're doing database operations? Do you have any tips and tricks for Ahmed?
Actually, by default, if you don't force FireDAC to do a full gather of data, it's pretty good at managing memory because it will be windowing, and there's even a advanced feature to force it to use only a certain set of rows at a time. So those that you have already passed browsing through get discarded automatically. They call it the windowing function. It's well documented. But even the default value, which is gathered by demand, doesn't use much memory. Only if you force the full gathering and it's a huge table, then you're running into trouble. But that's why FireDAC is really giving you a lot of tools to adapt to the exact case that you have. Something that, unfortunately, we didn't have with dbExpress. On dbExpress, you didn't have that fine-tuning capability of how to gather the data by pieces or chunks or the full thing. You didn't have that on dbExpress.
And then he's saying on the server side, and I'm saying use views on the server, on the SQL database server side. That's what they're for. If you want to, that's one of the things you can use to have sets of data on the server side that are always updated before you bring them over to the client side, right?
Well, right. And also there's something that I would love to show, but again, there wasn't enough time. FireDAC is fully replicating the advanced feature of cache mode that the BDE had, meaning that you have all your local updates cached until you post it to the server. You had this feature also with dbExpress. Actually, in dbExpress, there was no other way. There was no choice. You had to do it because of the architecture of the dataset provided and the client set. So everything was always cached. But on FireDAC, it's just one flag to toggle the cache updates or direct updates.
But thank you so much, Miguel.
Thank you so much for you, David.